Today's lesson, oxidation and reduction. According to modern concept of electrical concept. In this lesson, the points to be highlighted are oxidation, reduction, simultaneous process. That means oxidation and reduction occur simultaneously according to electrical concept. And finally, oxidation number. So, let's begin. The very first point is oxidation. What is oxidation? The chemical reactions in which loss of electron or electrons occurs. Those reactions are called oxidation. Let's see some examples. Suppose sodium at the time of compound formation, especially ionic compound, sodium loses one electron and sodium cation is formed. Similarly, magnesium loses two electrons and magnesium 2 plus ion is formed. Aluminium loses 3 electrons and aluminium 3 plus ion is formed. Again, ion 2 plus loses 1 electron and ion 3 plus is formed. Tin 2 plus loses 2 electrons and tin 4 plus ion is formed. Again, sulfur 2 minus loses 2 electrons and sulfur atom is formed. So, the reactions in which loss of electron or electrons occurs, those reactions are called oxidation reactions. In oxidation process, positive charge at the element increases and negative charge decreases. Here, negative charge 2 minus 2, this is 0. So, negative charge decreases and positive charge here plus 2 and here plus 3. So positive charge increases and negative charge decreases. Now let's see the complete definition of oxidation reactions. The reactions in which loss of electron or electrons occurs, those reactions are called oxidation reactions. In oxidation process, positive charge increases and negative charge decreases through loss of electron or electrons. Let's move on to the next point. Now the point is reduction. Reduction is a process in which gain of electron or electrons occurs. Now let's see some examples. Suppose chlorine at the time of compound formation, especially ionic compound, it gains 1 electron and chloride ion is formed. Similarly, oxygen gains 2 electrons and oxygen 2 minus ion is formed. Again, nitrogen gains 3 electrons and nitride ion is formed. This is nitride ion. Again, ion 3 plus receives 1 electron and ion 2 plus ion is formed. Similarly, tin 4 plus receives 2 electron and tin 2 plus ion is formed. And lastly, MnO4 minus. The name of this ion is permanganate ion. It receives 1 electron and manganate ion is formed. This is permanganate ion and this is manganate ion. Permanganate ion converts to manganate ion, receiving 1 electron. So these reactions are reduction reactions. The complete definition is the chemical reactions in which addition of electron or electrons occurs. Those reactions are called reduction reactions. In reduction process, positive charge decreases, that means +3 to +2. Positive charge decreases and negative charge increases, -1 to -2. -1, -2. So negative charge increases. Simply, the oxidation reactions are the chemical reactions in which addition of electron or electrons occurs. Those reactions are called reduction reactions. In reduction process, positive charge decreases and negative charge increases through addition of electrons. Let's move on to the next point. Now the point is oxidation and reduction occur simultaneously. That means oxidation will happen with the reduction and reduction will happen with the oxidation. Oxidation will not occur without reduction and reduction will not occur without oxidation. Now let's see some examples. First is the reaction between sodium and chlorine. When sodium is treated with chlorine, then sodium chloride is formed. If the reaction is balanced, then here we can put half. That means 1 chlorine atom. Though there is no existence of a half molecule, but for the sake of balance, we can put half here. Simply we can write sodium and chlorine form sodium chloride. In this reaction, sodium from its outermost shell releases 1 electron and chlorine accepts that electron. When sodium releases 1 electron, then sodium ion is formed and chlorine accepts that electron and chloride ion is formed. This loss of electron is known as oxidation, and here gain of electron occurs, which is known as reduction. So in the formation of sodium chloride, this electron will cut this electron, then sodium plus chlorine, sodium plus chloride minus, or simply we can write sodium chloride. So in the formation of sodium chloride, sodium donates electron, which is known as oxidation, and chlorine accepts that electron, which is known as reduction. So in the formation of sodium chloride, oxidation and reduction happen. That means oxidation and reduction occur simultaneously in this reaction. Let's see another reaction. Now the reaction is between magnesium and oxygen. When magnesium is treated with oxygen, then magnesium oxide is formed. If this reaction is balanced, then we can put 2 here, then 2 magnesium, here 2. That means in these reactions 2 magnesium atoms and 2 oxygen atoms are involved. Let's see here, 2 magnesium atoms. One magnesium atom donate 2 electrons. So 2 magnesium atom will donate 4 electrons here. And 2 magnesium 2 plus will be formed. The 4 electrons which are produced from magnesium will be accepted by 2 oxygen atoms. Here 2 oxygen atoms will accept these 4 electron and 2 oxygen 2 minus oxide ion will be formed, accepting 4 electrons. Here removal of electrons, which is known as oxidation, and here addition of electrons, which is known as reduction. So in this reaction 2 magnesium plus oxygen, these 4 electrons will cut these 4 electrons. Here 2 magnesium 2 plus and 2 oxygen 2 minus. That means simply we can write 2 magnesium oxide molecule. So in the formation of magnesium oxide, oxidation and reduction happen simultaneously. Let's see another reaction. The reaction is between zinc and copper sulfate. When solid zinc is added to copper sulfate solution, then zinc sulfate, aqueous and copper solid are formed. Let's see in this reaction how oxidation and reduction occur. Let's see this compound in the ionic form. Zinc solid plus copper 2 plus sulfate 2 minus. Here this is as ionic form. Zinc 2 plus sulfate 2 minus plus copper solid. In this reaction we see sulfate before chemical reaction and after chemical reaction remains same, which is called spectator ion. So in this reaction sulfate is a kind of spectator ion. But in case of zinc and copper, zinc is converted to zinc 2 plus. That means here release of 2 electrons occur. Release of electrons is known as oxidation, and copper 2 plus turns into copper. That means in this case addition of 2 electrons occurs. Addition of electrons is known as reduction. So in this reaction oxidation and reduction occur simultaneously. So we can say that the reaction in which oxidation occurs, reduction must occur in that reaction, which is known as oxidation and reduction simultaneous process. Let's see the next point. Now the point is oxidation number. We learned that formation of sodium chloride, magnesium oxide, and in the formation of sodium chloride we saw sodium donated electron to chlorine, and in magnesium oxide magnesium donated electrons to oxygen. In this way, sodium donated electron to chlorine and magnesium donated 2 electron to oxygen, and that is why we can write here at the top of the sodium +1, because in this compound sodium donated 1 electron and chlorine accepted that electron. That is why chlorine got negatively charged and sodium got positively charged. Sodium donated 1 electron, that is why +1. Chlorine accepted that 1 electron, that is why at the top of the chlorine -1. Actually these +1 and -1 are the oxidation numbers. And in magnesium oxide, magnesium donated 2 electrons, that is why at the top of the magnesium we can write +2, and oxygen accepted that 2 electrons, that is why -2 is written here. Magnesium donated 2 electrons, that is why +2. Oxygen accepted that 2 electrons, that is why -2. Here these +2 and -2 are the oxidation numbers. In aluminum chloride, aluminum donated 3 electrons, that is why +3, and these 3 electrons are accepted by 3 chlorine atoms. Chloride ion and chloride ion. These ions are formed. So in aluminum chloride, the charge of aluminum is +3. Chlorine is not -3. It will be -1, because each atom of chlorine element accepted 1 electron. That is why here -1. But 3 chlorine atoms accepted 3 electrons. But in this case it will be -1, because each chlorine atom accepted 1 electron. And here the oxidation number of aluminum is +3 and chlorine is -1 in the molecule aluminum chloride. Now let's see the definition of oxidation number. The number of electrons donated or accepted by one atom of any element is called oxidation number. So here important point is that by one atom, number of electrons donated or accepted by one atom of any element in a molecule is called oxidation number. So in sodium chloride, the oxidation number of sodium is +1 and chlorine is -1. In magnesium oxide, oxidation number of magnesium is +2 and oxygen is -2. In aluminum chloride, oxidation number of aluminum is +3 and chlorine is -1. These are the ionic compounds. So in these compounds, donation of electron and acceptance of electron occur. But there are some compounds like water, hydrogen chloride. These compounds are covalent compounds. No donation or acceptance occurs. So in this case, oxidation number is considered in this way. That is, here the oxygen is a higher electronegative element than hydrogen. Electronegativity of hydrogen is 2.1 and oxygen is 3.5, 2.1. So oxygen gets negatively charged and hydrogen gets positively charged because electronegativity of oxygen is higher than hydrogen. So it is +1, this is +1, this is -2. So in water molecule, oxidation number of hydrogen is +1 and oxygen is -2. In hydrogen chloride, the electronegativity of chlorine is 3.0 and hydrogen is 2.1. Since electronegativity of chlorine is higher than hydrogen, chlorine gets negatively charged and hydrogen gets positively charged. So oxidation number of hydrogen is +1 and chlorine is -1 in hydrogen chloride. So in this way, oxidation number is calculated in ionic compounds and in covalent compounds as well. No more today. Thank you very much. Take care.